Hi guys, my name is Lu, a third year student from Materials Engineering, and my metric number is 143407. Today I'm going to present a corroded sample and analyze how this sample become corroded. The sample is the swing in my house. The base of the swing became corroded after several years. Here is another photo showing the corroded part at the base of the swing, and here is the dot at behind. I will explain later why the dot is another reason for this corrosion occur at the base of this swing. Now, let's zoom in further for the base of the swing. Here showing the base of the swing with pitting corrosion resulting a big hole at the bottom, and another region where pitting corrosion is starting to occur. As for pitting corrosion, it is caused by local dissolution of the metal surface and leads to the formation of the deep localized pits in the passivated metal, exposed to the aqueous media with dissolved salt. Pitting corrosion is the localized accelerated dissolution of metal that occurs as a result of the breakdown of the passive protective film on the metal surface. The dissolved salt and ions, such as chloride, can interfere with the formation of the protective film and resulting the pitting corrosion. Then this metal oxide layer that form on the metal surface can be then weakened by the insertion of the chloride into the metal oxide film, forming the metal chloride complex. This metal chloride complex form is more soluble in aggressive aqueous environments, and the metal surface exposed to this aggressive aqueous environment will result in pitting corrosion. Let's look back to this photo again. As we can see that the slightly more brownish color at the base of the swing indicated that this previously was a metal oxide layer formed at here. Then the oxide layer is being weakened by the insertion of the chloride into the metal oxide film, forming the metal chloride complex, and thus leading to the pitting corrosion when the metal surface is exposed to the surrounding environment. Then now you can see that at the top there, right above the hole, there's another region is being indicated that the metal oxide layer is started to be perforated, exposing the fresh metal surface to the atmosphere. Sooner or later, here will be another region where the pitting corrosion occur, and the holes will become bigger. Let's analyze why pitting corrosion occur at the bottom of the swing. Firstly, I would like to clarify that my dog loves to pee at the bottom of the swing there. That's probably the main reason why pitting corrosion so severe at there. In dog's urine, it contains chloride ion and uric acid, which is a weak acid, therefore creating an aggressive environment for the pitting corrosion to occur. This chloride ion is able to weaken the metal oxide layer formed on the swing, then intrude into the fresh new metal surface, forming metal chloride complex, and become aggressive environment for pitting corrosion to occur. Besides, the base of the swing is consistently in contact with the ground level, and when raining, the rainwater often accumulated at there. This leads to the formation of the metal oxide layer first, then with the addition of my dog's urine at there, the metal oxide layer breaks down and forming the pits. Now, here is a simple mind map illustrating why pitting corrosion occur. Firstly, during normal day, when raining, the rainwater will accumulate at the base of the swing there, and therefore forming metal oxide layer with the presence of oxygen. Then my dog also seldom pees at the base of the swing there, resulting uric acid and chloride contents at there. Therefore, the breakdown of the metal oxide layer, forming the pits exposing the new fresh metal surface. Thus, pitting corrosion occur. Now let's discuss about the mechanism of the pitting corrosion. This formation of pits involves several mechanisms. Firstly, it forms normal iron oxide at the base of the swing according to the anodic oxidation and cathodic reduction as shown here. Then, adsorption of the chloride ions into the surface layer of the iron oxide film. It slowly breaks down the oxide film and exposing the new metal surface. Then rapid oxidation of iron occurs, forming the iron chloride complex. Then dissolution of this chlorinated complex and forming the pits. Inside the pits, hydrolysis of chlorides causing the acidification to keep the pitting active. Therefore, the pitting corrosion can be propagated continuously. To analyze pitting corrosion, we can measure pit depth. Pit depth is generally a better indicator than measure the mass loss in determining a localized corrosion attack. Pitting depth is can be defined as this equation: d equal lambda t power n. Pit depth measurement can be accomplished by several methods, which are microscopic method and X-ray radiography method. In microscopic method, a powerful microscope can be used to focus the top and bottom of the pits, then measure the difference to analyze the pit depth. High-power digital microscope can analyze pit depth, pit volume, and area of the pit. The sample that underwent pitting corrosion is placed on the stage directly under the lens, and the microscope will act as the digital camera by showing the images to the monitor. The microscope can capture the 2D measurements in real time, which is then can be converted into 3D images and 3D profiles. With these 3D model images and profile, the pit depth can be measured accurately. Here is an example of the high-power digital microscope. Next, in X-ray radiography method, it is an easy method to quantify pitting corrosion, both in terms of pit depth and the area affected in percentage. This is a non-destructive testing technique which can be used to monitor and detect a severe corrosion attack on the metal surface. The X-ray beam penetrates the surface of the metal and creates a variable intensity of the transmitted beam. In the resulting X-ray photograph, the low intensity beam would cause a dark image and the high intensity would give a brighter image. And here shows the schematic diagram of the X-ray radiography. The solution to reduce this pitting corrosion is to prevent the swing further contacting the ground level on the floor, so that it will be a less aggressive environment to reduce the pitting corrosion. This can be done by welding an extra stainless steel rod at the bottom of the swing, which can raise up the base of the swing and prevent the base of the swing in contact with the floor. Thus, the pitting corrosion or any formation of the metal oxide at the base of the swing can be reduced. Besides, paint coating can be applied constantly on the swing from time to time as a maintenance to reduce the pitting corrosion and oxide form on the metal surface. Thank you for watching. That's all from me.